Welcome to Slumbertainment. Get comfortable, close your eyes, and let yourself relax. Tonight we examine the Loch Ness Monster. Please like and subscribe for more restful content. Now, let's begin. There is a place in the northern reaches of Scotland where the land splits open like an old wound. A long, narrow valley runs from southwest to northeast, cutting through the heart of the Highlands as though drawn by a single, deliberate stroke. The valley is ancient, far older than the country that now surrounds it, and at its floor, fed by rivers and rainfall and the slow weeping of surrounding hills, lies one of the most unusual bodies of water in the world, Loch Ness. The name is spoken quietly in some places and with a kind of knowing smile in others. To many, it conjures images of a long neck rising from dark water, or a grainy photograph passed around a breakfast table. But before any of that, before the photographs, before the newspaper headlines, before the television crews and the sonar equipment and the scientific debates, there was simply the loch itself, cold, dark and immense. A body of water that existed long before anyone thought to name it, and that will likely exist long after the last argument about what lives inside it has faded away. To understand the mystery of Loch Ness, it helps to first understand the place. Not the legend, not the creature, just the water and the rock and the particular quality of silence that settles over the valley on a still morning. The loch sits within the Great Glen, a geological fault line that divides the Scottish Highlands from northwest to southeast. This fault is not a recent feature. It formed roughly 430 million years ago, during a period when the land masses that would eventually become Scotland and North America were pulling apart from one another. The movement of those ancient plates left a deep scar in the earth, and over millions of years, that scar filled with water. What resulted is a loch of remarkable proportions. Loch Ness stretches for approximately 23 miles in length and reaches widths of around 1 mile across, but it is the depth that tends to stop people mid-sentence. At its deepest point, Loch Ness plunges to around 750 feet, deeper than most of the North Sea, and deep enough that the entire population of the world could be submerged within it without the water level rising noticeably. It holds more fresh water than all the lakes of England and Wales combined. These are figures that are easy to repeat, but harder to truly absorb. Standing on the southern shore on a grey afternoon, looking out across the water, it is difficult to comprehend what lies beneath the surface. The loch does not give anything away. It simply sits there, dark and level, reflecting the clouds above it. That darkness is one of the loch's most distinctive qualities, and it has a straightforward explanation. The surrounding hills are composed largely of peat, that dense, decomposed organic matter that blankets much of the Scottish Highlands. When rainwater flows across peat and down into the loch, it carries fine particles of dissolved organic material with it. These particles tint the water a deep, reddish brown that absorbs light rather than allowing it to penetrate. Even on a bright day, visibility in Loch Ness extends to only a few feet below the surface. Beyond that, there is nothing but darkness. This feature, the peat-stained water, the near-total absence of light at depth, has shaped almost every aspect of the Loch Ness mystery. It is why photographs taken from boats tend to show only the surface. It is why divers who have entered the loch describe an unsettling experience of near total blindness just meters below the waterline. And it is why, even with modern technology, the floor of the loch remains poorly understood. The loch does not freeze in winter. Its sheer volume of water retains heat with a kind of stubborn efficiency, maintaining a relatively stable temperature year-round of around 5 to 6 degrees Celsius. cold but not frozen, still but not stagnant. The water circulates in slow, deep patterns driven by temperature differences between the upper and lower layers, a process called thermohaline circulation, though on a much smaller scale than the oceanic systems that share the name. There are several rivers that feed into Loch Ness, and one that flows out, the River Ness, which runs northeast toward the city of Inverness and eventually into the Moray Firth. The loch is also connected via the Caledonian Canal, an engineered waterway completed in 1822, to both the east and west coasts of Scotland, allowing vessels to pass from one sea to the other without circumnavigating the entire country. This means that Loch Ness is not entirely isolated. It is, in a quiet and overlooked way, connected to the wider ocean. That detail has not been lost on those who have speculated about what might inhabit the loch. The surrounding landscape is dramatic in the way that much of the Scottish Highlands is dramatic, not with sharp peaks and sudden drops, but with a kind of accumulated weight. The hills rise steeply from the water's edge, covered in heather and bracken and stands of Scots pine. In summer, the valley holds a particular green that seems almost too vivid, too saturated, as though the light is working harder here than elsewhere. In winter, the colour drains away, and the loch takes on a pewter quality, flat and expressionless beneath low cloud. Few people live immediately on the loch's shores. There are small villages, Drumnadrochit on the western bank, Fort Augustus at the southern end, and the ruins of Urquhart Castle, which clings to a promontory midway along the northern shore as though reluctant to let go of the hillside. The castle is a relic of medieval Scotland, partially destroyed in the late 17th century to prevent it from falling into Jacobite hands. It is one of the most visited sites in Scotland now, and on busy days in summer, tourists line the low walls and look out across the water. What they are looking for is always the same thing. The loch has a way of doing this to people. Even those who arrive with no particular belief in monsters find themselves scanning the surface as they walk along the shore road, or pausing at a viewpoint to watch a ripple that might have been caused by the wind, but might, just conceivably, have been something else. The water invites that kind of attention. Its darkness, its depth, its cold stillness, all of it suggests that something could be hidden there, even if reason argues otherwise. That tension between the rational and the imagined, between the measurable and the unknown, runs through the entire history of Loch Ness. It begins not with cameras or newspapers or scientific expeditions, but with the people who lived alongside this water for centuries before any of those things existed. People who looked out at the same dark surface, felt the same unease, and told stories that have never quite gone away. Those stories are where this journey begins. Long before the first newspaper carried a story about a monster in a Scottish loch, long before the word Nessie existed in any language, the people who lived along the shores of Loch Ness were already telling stories about what lived in the water. These were not the kinds of stories told for entertainment, or at least not only for that. They were the kinds of stories that served a purpose. Warnings, explanations, attempts to make sense of a landscape that could feel, on certain days and in certain lights, genuinely threatening. The Highlands of Scotland were not an easy place to live. The winters were long, the land was difficult, and the loch, vast, dark and unpredictable, was a presence that could not be ignored. The people who inhabited this region in the early medieval period were largely Pictish, members of a culture that occupied much of northern Scotland before the gradual spread of Gaelic influence from the west. The Picts left behind carved stones scattered across the landscape, many of them decorated with animals both recognisable and strange. Among the recognizable ones are deer, wolves, eagles, and salmon. Among the strange ones is a creature that appears repeatedly on Pictish stones found near bodies of water throughout Scotland. A long-bodied, flipped animal with an elongated snout, sometimes called the Pictish beast. What this carving represents is not known with certainty. Some researchers suggest it is a stylized dolphin or porpoise, rendered in the distinctive geometric style of Pictish art. Others have noted, with varying degrees of seriousness, that it bears a passing resemblance to descriptions of the creature that would one day be called the Loch Ness Monster. The honest answer is that no one knows. The Picts left no written language, and their carvings speak in a visual vocabulary that has never been fully decoded. What is known is that the water-dwelling creature was a significant figure in early Scottish mythology. In Gaelic tradition, the most prominent of these was the Each Uisge, the water horse. This creature was said to inhabit lochs and rivers throughout the Highlands, and it was not a benign presence. The water horse was described as a shapeshifter, capable of appearing as a beautiful horse grazing peacefully by the water's edge, or sometimes as a handsome young man. The danger lay in what happened if you were foolish enough to approach or mount it. The creature would drag its victim into the depths of the loch and devour them, leaving behind only the liver, which would float to the surface the following morning. Stories of the Each Uisge were told as cautionary tales, particularly to children who might otherwise be tempted to approach the shore or the water's edge unattended. In a time before fences and safety notices, such stories had practical value. A child who believed a monster lurked in the loch was a child less likely to wander too close to its edge. The related creature, the kelpie, served a similar function, but was more commonly associated with rivers and streams than with still water. Both the Each Uisge and the kelpie appear throughout Scottish folklore with remarkable consistency, suggesting that they were not isolated local beliefs, but widely shared traditions, passed down through generations across a broad geographic area. Against this backdrop of mythology and water lore, the first written account associated specifically with Loch Ness takes on a particular significance. It comes from the life of Saint Columba, a biography written by the monk Adamnan around 690 AD, more than 1300 years ago. Columba was an Irish monk who travelled to Scotland in the 6th century and established a monastery on the island of Iona, from which he conducted missionary work throughout the Highlands. According to Adamnan's account, Columba was travelling through the region of the River Ness when he encountered a group of local people burying a man who had just been killed by a creature in the water. Columba, displaying the kind of calm authority that hagiographers tended to attribute to saints, ordered one of his companions to swim across the river to retrieve a small boat moored on the other side. The companion, a monk named Lugne Mocumin, dutifully entered the water. At that moment, the creature reappeared, described as rising from the water with a great rush, its mouth wide open, heading directly for Lugne. Columba raised his hand, made the sign of the cross, and commanded the creature to go no further. The creature, according to Adamnan, stopped as though it had been pulled back by a rope and retreated into the water. The account is remarkable for several reasons. It is the earliest written record of a creature in the waters associated with Loch Ness. It treats the creature not as a mythological figure, but as a real physical entity that was present and dangerous. And it frames the encounter not as a legend, but as a historical event, narrated in the manner of a factual account, with named individuals and a specific geographic location. Historians and folklorists have treated this passage in different ways. Some have pointed out that Adamnan was writing more than a century after Columba's death, and that the account may have been shaped or embellished in the retelling. Others have noted that early hagiographies routinely included miracle stories of this kind, and that the encounter with the creature was likely included to demonstrate Columba's divine authority rather than to document a genuine zoological encounter. The River Ness, strictly speaking, is not the same as Loch Ness itself, though the two are connected, and yet the account has endured. It is cited in almost every serious history of the Loch Ness phenomenon, and for good reason. Whether or not it describes a real animal, it establishes something important, that the waters of this region were associated, even in the earliest recorded history of the area, with something dangerous and unknown. The centuries that followed produced scattered references, a mention here, a local legend there, but nothing that rose to the level of documented testimony. The loch continued to sit in its valley, dark and cold, and largely untroubled by outside attention. The people who lived nearby no doubt continued to tell their stories, as people always have. But for hundreds of years those stories stayed local, passed between communities that had no particular reason to share them with the wider world. That began to change slowly, as the world itself began to change. Roads were built into the highlands, maps were drawn, travellers began moving through regions that had previously been accessible only to those who lived there, and with that increased movement came increased observation. More eyes on the loch, more opportunities for something to be seen or imagined or reported. The modern story of the Loch Ness Monster did not begin in the 20th century. It had roots that went much deeper, down through centuries of folklore, through the accounts of monks and missionaries, through the carvings of a people whose language has never been read. By the time a local newspaper in 1933 published the account that would change everything, the loch had already been holding its secrets for a very long time. In the spring of 1933, a new road opened along the northern shore of Loch Ness. It had been carved out of the hillside over several years, blasting through rock and clearing trees to create a route that finally gave travellers a clear, unobstructed view of the water below. For most of the loch's history, the surrounding terrain had made it difficult to see much of the surface at all. The trees grew close to the edge, the hills were steep, and the few roads that existed ran inland rather than along the shore. The new road changed that. For the first time, it was possible to drive alongside the loch for miles, with the water spread out in full view to one side. More eyes on the loch, more chances to see something. On the 2nd of May 1933, a couple named John and Aldi Mackay were driving along this new road near the village of Abriacan. John Mackay was a local hotel manager, a practical man with no particular interest in folklore or legend. His wife was alongside him in the passenger seat. It was a calm afternoon, and the loch was visible through the windscreen as they drove. What Aldi Mackay saw, or believed she saw, was a large disturbance in the water some distance from the shore. She described it as a tremendous upheaval, as though something enormous was rolling and plunging in the loch. There was no wind that afternoon. The surface elsewhere was undisturbed. Whatever was causing the commotion, it was concentrated in one area, and then it was gone, leaving only the slow settling of waves where the disturbance had been. The Mackays mentioned what they had seen to a local water bailiff named Alex Campbell, who happened to also work as a part-time correspondent for the Inverness Courier, the regional newspaper that served the area. Campbell, recognising a story when he heard one, wrote up the account and submitted it to the paper. On the 2nd of May 1933, the Inverness Courier published the report under the headline, "Strange Spectacle on Loch Ness." The editor of the paper, a man named Evan Barron, made a decision that would turn out to be consequential. In describing the creature, he used the word monster. It was not a word the Mackays themselves had used. It was an editorial choice, the kind of small decision that shapes perception in ways that are difficult to undo. From that point forward, whatever was or was not in Loch Ness would be known in the public imagination as a monster. The article did not immediately cause a sensation beyond the local area, but it did prompt others to come forward. In the weeks and months that followed, additional witnesses contacted the paper with their own accounts. People who had seen something unusual on the loch and had previously said nothing, either because they had no one to tell or because they feared not being believed. A sighting reported in a newspaper gave others permission to speak. The Mackay account had established a precedent. This was a thing that could be said out loud. By the summer of 1933, the story had begun to travel. London newspapers picked it up. The Daily Mail and other national titles ran their own versions of the story, and the language grew more vivid with each retelling. What had been described as a disturbance in the water became, in some accounts, a creature of enormous size. Details multiplied. Descriptions became more specific, though they did not always agree with one another. One account that attracted particular attention came from a couple named George Spicer and his wife, who reported that in July of that year they had been driving along the Southern Shore Road when they saw something cross the road directly in front of their vehicle. They described a large, ungainly creature with a long neck and a heavy body, moving in a lurching manner toward the loch. It disappeared into the undergrowth before they could get a clear look. George Spicer later described the neck as undulating and estimated the creature's body to be around 4 feet high and 25 feet long. The Spicer account was significant for several reasons. It was the first report that placed the creature on land rather than in the water, and it introduced the long neck detail that would become central to the popular image of the Loch Ness Monster. It was also, unlike a disturbance seen at a distance across the water, a close-range encounter described by two people simultaneously. Spicer was a businessman from London, not a local, not someone with any obvious reason to fabricate a story about a Scottish loch. Skeptics have pointed out that the Spicer's account was given some time after the event, and that the couple may have been influenced by the growing media coverage of the story. Memory is malleable, particularly when a cultural narrative is forming around an experience that might otherwise be difficult to explain. A large animal crossing a road, perhaps an otter, a deer, or some other creature glimpsed briefly and in poor light, could be reconstructed in the mind into something more remarkable, especially if the mind has already been primed by newspaper stories about monsters. But this observation cuts in two directions. It explains why some accounts might be exaggerated or misremembered. It does not explain why multiple people, in different locations and different circumstances, were reporting broadly similar things. By the end of 1933, the Loch Ness Monster had become a national story in Britain and was attracting attention further afield. Expeditions were being discussed. Journalists were travelling north. The Highlands, which had for so long been a remote and overlooked corner of the country, suddenly found itself at the centre of something that the public could not get enough of. The timing was not incidental. Britain in 1933 was a country still finding its way out of economic depression. The newspapers were hungry for stories that offered escape and wonder. A monster in a Scottish loch, ancient, mysterious, impossible to confirm or deny, was exactly the kind of story that could hold a readership's attention through weeks of follow-up reports and speculation. The loch had not changed. The water was the same as it had always been. Dark, deep, and indifferent to the attention being directed at it, but the world looking at the loch had changed considerably. And it was about to change again, with the arrival of a photograph that would fix the image of the Loch Ness Monster in the public imagination for decades to come. Of all the images associated with the Loch Ness Monster, one has endured above all others. It is a black and white photograph, slightly blurry, showing what appears to be a long, curved neck and small head rising from the surface of dark water. The water around it is disturbed. The sky is pale. The creature, if it is a creature, occupies only a small portion of the frame, which somehow makes it feel more real rather than less. It looks like something caught by accident, the way genuine surprises always do. This image, taken in April of 1934, became known as the surgeon's photograph. For more than 60 years, it was considered the single most compelling piece of visual evidence that something unusual lived in Loch Ness. It appeared in newspapers around the world. It was reproduced in books, documentaries, and encyclopedias. It became, in a very real sense, the face of the mystery, the image that most people picture when they hear the name Loch Ness Monster. The story of how the photograph came to exist is, on the surface, straightforward. A London physician named Robert Kenneth Wilson was visiting the Highlands in early April of 1934. On the morning of the 19th, he was driving along the Northern Shore Road when he noticed a disturbance in the water. He stopped the car, retrieved a camera from the back seat, and took 2 photographs before the object, whatever it was, disappeared beneath the surface. Wilson was reportedly reluctant to attach his name to the photographs. He was a respected physician and had a professional reputation to consider. When he eventually allowed the images to be published, he asked that he not be identified as the source. The Daily Mail, which acquired the photographs and published them in April of 1934, referred to him only as a surgeon. The name stuck, and the image became known as the surgeon's photograph, even after Wilson's identity became publicly known. The photographs caused an immediate sensation. The first image, the one that would go on to become iconic, showed what appeared unmistakably to most observers as a living creature. The neck was long and graceful, curving above the waterline. The head was small, slightly turned, as though the animal had been caught in the act of looking around. It resembled, more than anything else, the popular conception of a plesiosaur, the long-necked marine reptile of the Mesozoic era that had become, in the early 20th century, something of a cultural shorthand for prehistoric sea creatures. The timing of the photograph's publication was important. It arrived at a moment when public interest in the Loch Ness story was still high, but beginning to need fresh fuel. The initial wave of sightings from 1933 had generated enormous coverage, but coverage requires new developments to sustain itself. The surgeon's photograph provided exactly that, a concrete visual piece of evidence that the public could look at and form their own opinion about. It was no longer just a matter of taking someone's word for what they had seen. Scientists and naturalists responded with varying degrees of caution. Some were willing to entertain the possibility that the photograph showed a real animal. Others pointed out that it was impossible to determine the scale of the object from the image alone, and that what appeared to be a large creature at a distance could equally be a much smaller object. A bird, an otter, a piece of debris, close to the camera. Without a reference point, the eye cannot judge size, and the eye, as it turns out, is remarkably willing to be deceived. For most of the 20th century, however, the photograph held its authority. There were periodic challenges, researchers who argued it showed an otter's tail, or a diving bird, or a floating log shaped by chance into something suggestive. But no definitive debunking emerged, and the image retained its place at the centre of the Loch Ness legend. The truth, when it finally came, arrived not through scientific analysis, but through a deathbed confession. In 1994, a man named Christian Sperling, then in his 90s, told researchers that the surgeon's photograph was a hoax. Spurling was the stepson of Marmaduke Wetherell, a big game hunter who had been hired by the Daily Mail in 1933 to search for the Loch Ness Monster and had suffered a humiliating public embarrassment when the tracks he identified near the loch's edge turned out to have been made with a hippopotamus foot. Likely from a decorative ashtray. Wetherell, according to Spurling, had decided to take revenge on the newspaper that had mocked him. The plan was relatively simple. Spurling, who had experience with models and construction, built a small creature from plastic wood and attached it to the conning tower of a toy submarine purchased from Woolworths. The neck was around a foot tall. The finished model was taken to Loch Ness and photographed floating on the surface. When the images were developed, they were passed through an intermediary to Wilson, who agreed to present them as his own discovery. His reputation as a respectable professional lent the photographs a credibility they would not otherwise have had. The confession was credible. It came from a man with no obvious motive to fabricate it, who had waited until he was old and had little left to lose. Subsequent analysis of the photograph found it consistent with a small model rather than a large animal. The object in the image, researchers concluded, was probably between 18 inches and 2 feet in height. Not the towering presence the popular imagination had constructed around it. The revelation was, for many people, genuinely deflating. The most famous piece of evidence in the entire history of the Loch Ness Monster had been a toy submarine in a Scottish loch. The image that had shaped the public understanding of what the creature looked like, that had influenced decades of sightings and descriptions, was a fabrication born from a wounded man's desire for revenge. And yet something important remained. The surgeon's photograph may have been a hoax, but the sightings that preceded it were not. The people who had reported disturbances and creatures in the water before 1934 had nothing to do with Wetherell or Wilson or toy submarines. The photograph had always been just one thread in a much longer story, and pulling it out, it turned out, did not unravel everything else. The mystery, stripped of its most famous image, continued on. The Second World War had a quieting effect on many things, and the Loch Ness Monster was among them. The years of conflict between 1939 and 1945 pulled public attention toward more pressing concerns, and the remote Scottish Highlands were no longer a destination for journalists or curious travellers. The loch returned to something closer to its old obscurity, watched, as it had always been, by the people who lived nearby, but largely ignored by the wider world. When the war ended and everyday life began to reassemble itself, the story returned with it. The late 1940s and 1950s brought a renewed wave of reported sightings, and with them a new kind of interest. Less sensational than the newspaper frenzy of the 30s, but in some ways more serious. People began to ask not just whether the creature existed, but how one might go about finding out. Among the most significant figures of this period was a man named John Cobb, though his connection to the loch was not primarily about the monster. In September of 1952, Cobb, a wealthy London fur broker and speed enthusiast, attempted to break the water speed record on Loch Ness in a jet-powered boat called Crusader. The attempt ended in tragedy when the boat disintegrated at high speed and Cobb was killed. He remains a respected figure in the history of the loch, and a memorial cairn stands on the northern shore near where the accident occurred. Cobb's attempt had brought camera crews and journalists to the loch, and in the coverage that surrounded the event, the monster story resurfaced in the press. Witnesses were interviewed. Old accounts were revisited. The cycle of attention that the loch seemed to generate, periods of quiet followed by sudden renewed interest, repeated itself once more. It was in this climate that a man named Constance White published a book in 1957 that would prove important to the serious study of the phenomenon. White, the wife of the manager of the Caledonian Canal, had spent years collecting witness testimonies from people who lived and worked around the loch. Her book, titled More Than a Legend, brought together dozens of accounts from local people. Farmers, fishermen, schoolteachers and loch workers who had seen something they could not explain. White was careful and methodical. She did not claim to know what the creature was. She simply documented what people said they had seen and presented it as a body of evidence worthy of proper investigation. The book attracted the attention of a naturalist and documentary filmmaker named David James, who became convinced that the witness testimony collected by White represented something genuinely worth investigating. James was a former Member of Parliament with organisational ability and a talent for bringing people together, and in 1962 he co-founded what became known as the Loch Ness Phenomena Investigation Bureau, a volunteer organisation dedicated to systematic observation of the loch. The Bureau, as it became known, established a permanent watch on the loch's surface. Volunteers set up camera stations at various points along the shore, equipped with long lens cameras capable of photographing distant objects on the water. Rotors were organised, logbooks were kept, and sightings were recorded in as much detail as possible. At its peak in the late 1960s, the Bureau had hundreds of volunteers and was operating multiple observation posts simultaneously. The approach was disciplined and deliberate. The Bureau's founders understood that the central problem with Loch Ness evidence was its anecdotal nature, people describing what they had seen without any independent means of verification. What was needed was photographic or physical evidence obtained under controlled conditions by trained observers using proper equipment. The Bureau's watch program was an attempt to create those conditions. The results were mixed. Over the years of operation, the Bureau accumulated a collection of photographs and film footage showing objects on the surface of the loch that were difficult to identify with certainty. None of it was conclusive. The dark water, the distances involved, and the unpredictable nature of whatever was or was not appearing on the surface made clean, definitive images almost impossible to obtain. One piece of footage from this period attracted particular attention. In 1960, a man named Tim Dinsdale, an aeronautical engineer who had become deeply interested in the Loch Ness question, filmed what appeared to be a large, hump-shaped object moving across the surface of the loch near the village of Foyers. Dinsdale had spent 6 days watching the loch before capturing the footage on the final morning of his stay. The object moved at speed, leaving a distinct wake before disappearing. Dinsdale was so affected by what he had filmed that he gave up his engineering career and spent much of the rest of his life investigating the loch. The Dinsdale film was later analysed by the Joint Air Reconnaissance Intelligence Centre, a British military photographic analysis unit, which concluded in 1966 that the object in the footage was probably an animate object and was unlikely to be a surface vessel. This was not a trivial endorsement. The unit had no reason to reach a dramatic conclusion, and its analysis was cautious and qualified, but the finding gave the Dinsdale film a degree of credibility that amateur footage rarely receives, and it renewed serious interest in the question of what might be in the loch. Through the 1960s, the investigation of Loch Ness became a small but genuine area of inquiry, attracting people with scientific backgrounds who were willing to set aside the ridicule that often accompanied any association with the subject. The Bureau continued its work. Researchers visited from universities. Equipment became more sophisticated, and the witnesses kept coming. Fishermen who had worked the loch for decades described encounters that they spoke about with quiet certainty and no apparent desire for attention. A local schoolmaster reported watching a large creature on the surface for several minutes through binoculars. A group of schoolchildren on a field trip claimed to have seen something rise briefly from the water near the shore. What was striking about many of these accounts was their similarity. The details varied: the exact shape, the distance, the conditions of light and weather, but a core description recurred with notable consistency. A large dark body, one or more humps visible above the waterline, movement that seemed purposeful rather than random, and then, almost always, a quiet return to the surface, and nothing left but the ordinary water. Whether these witnesses were all seeing the same thing, or different things, or things that existed only in the gap between perception and imagination, remained an open question. The Bureau's cameras watched the loch, and the loch, as always, kept its own counsel. But the tools available to investigators were about to become considerably more powerful. The next chapter in the Loch Ness story would move from cameras on the shore to instruments beneath the water, into the darkness where no human eye had yet properly looked. By the early 1970s, the question of what lived in Loch Ness had attracted the attention of people who approached it not with cameras and logbooks, but with instruments. The technology that had reshaped underwater exploration in the post-war decades. Sonar, underwater photography, submersible vehicles, was becoming more accessible, and a small number of researchers began to ask whether it could be brought to bear on the problem of the loch. Sonar works by emitting sound pulses into water and measuring the echoes that return. Dense objects, fish, the loch floor, submerged structures, reflect those pulses back to the instrument, producing a picture of what lies beneath the surface. It had been used extensively by navies during the war to detect submarines, and in the years that followed it became a standard tool in marine biology, fisheries management, and oceanographic research. Loch Ness, with its dark and impenetrable water, was in many ways an ideal candidate for sonar investigation. What the eye could not see, sound might reveal. The first significant sonar study of the loch was conducted in 1968 by a team from the University of Birmingham, led by a professor named D.G. Tucker. The team towed a sonar unit across sections of the loch and analysed the echoes that returned. On several occasions, they recorded signals that they could not immediately account for. Large, moving targets at depth that did not correspond to the known fish population of the loch. The signals appeared and disappeared. They moved in ways that suggested animate behaviour. Tucker was cautious in his conclusions, but he did not dismiss what his instruments had recorded. He suggested that the loch might contain large animals of an unknown species and recommended further investigation. The Tucker study was followed by several others over the course of the 1970s. The most ambitious and widely reported of these was conducted by the Academy of Applied Science, a Boston-based organisation led by a lawyer and amateur scientist named Robert Rines. Rines was a man of considerable energy and resources, and he brought both to bear on Loch Ness over a series of expeditions beginning in 1972. Rines and his team combined sonar with underwater photography, an approach that had not previously been tried in the loch. The idea was straightforward. Use the sonar to detect large objects in the water, then trigger an underwater camera automatically when a significant target appeared. If something large was moving at depth, there was at least a chance of capturing it on film. The results of the 1972 expedition were intriguing but ambiguous. The sonar recorded a large moving contact in the water near the bottom of the loch, and the camera triggered as intended. When the photographs were developed, they showed what appeared to be a large diamond-shaped object, possibly a flipper or fin, attached to a body that was largely outside the frame. The image was blurry, as underwater photography in dark conditions tended to be, and it was taken at close range with a wide-angle lens, which distorted the proportions of whatever it showed. The photograph attracted significant attention. Researchers at the Jet Propulsion Laboratory in California, which had expertise in image enhancement developed for the space program, processed the image to improve its clarity. The enhanced version appeared to show a textured, diamond-shaped flipper, large enough to suggest an animal of considerable size. The comparison to the flipper of a plesiosaur was made widely and enthusiastically. Rines returned to the loch in 1975 with improved equipment. This expedition produced 2 photographs that caused a genuine stir in scientific circles. One appeared to show a long-necked creature with a bulky body. The other seemed to show a close-up of a head, with features that some observers interpreted as a mouth, an eye, and a horn-like protrusion. Rines was sufficiently confident in the images to present them to a joint session of the House of Commons and the House of Lords in London, attended by scientists and politicians, under the title of a formal scientific presentation. The response from the broader scientific community was divided. Some researchers, including Sir Peter Scott, the respected naturalist and wildlife artist, took the evidence seriously enough to propose a formal scientific name for the creature, Nessiteras rhombopteryx, meaning the Ness wonder with the diamond-shaped fin. The name was partly a practical measure. Under British law, a species needed a formal name before it could receive legal protection. The naming was intended to lay the groundwork for protecting the animal in the event that its existence was confirmed. Others were deeply sceptical. Critics pointed out that the photographs were of very poor quality and that the features identified in them, the neck, the head, the flipper, were interpretations of blurry shapes rather than clear anatomical evidence. The human visual system is extraordinarily good at finding familiar forms in ambiguous images, particularly when it already expects to find them. A photograph that shows something that might be a flipper, examined by researchers who believe a large animal is present, is likely to be interpreted as a flipper. This tendency, called pareidolia in its more extreme forms, is not unique to any individual. It is a feature of how all human minds process uncertain visual information. The sonar results, taken separately from the photographs, were harder to dismiss. Multiple independent sonar surveys of the loch during the 1970s recorded large, moving contacts at depth. Objects significantly bigger than any fish known to inhabit the loch, moving in ways consistent with animal behaviour. A 1979 survey conducted by the Loch Ness and Morar project recorded a contact estimated to be between 6 and 9 metres in length, moving at depth along the loch floor. What those contacts were remained, as always, uncertain. Sonar is not a camera. It records size, movement and depth, but it does not identify. A large sonar return might be a large animal. It might also be a thermal layer in the water, a column of rising gas from the loch floor, or an unusual aggregation of smaller organisms. The loch's geology, with its peaty sediment and its complex internal circulation, was capable of producing acoustic effects that could mislead even careful operators. By the end of the 1970s, the scientific case for something large and unknown in Loch Ness was neither proven nor disproven. The instruments had found things they could not immediately explain, but they had not found the clear, unambiguous evidence that the scientific community required. The loch had yielded hints, suggestions, partial images caught at the edge of what the technology could reveal. It was enough to keep the question alive, and it was enough to keep people asking the next, more fundamental question. If something was there, what on earth could it be? Of all the explanations proposed for the Loch Ness Monster, one has proven far more durable than any other. It is an idea that took hold in the earliest days of the modern legend and has never entirely loosened its grip, despite the considerable scientific objections raised against it. The idea is this, that somewhere in the dark water of the loch, a remnant population of plesiosaurs, marine reptiles that lived during the age of the dinosaurs, has survived, largely unchanged, into the present day. The plesiosaur theory has a certain elegant appeal. It accounts for the long neck, the large body, the flippers, and the general impression of something ancient and primordial. It connects the Loch Ness Monster to a real and well-documented creature from the fossil record, lending the idea a scientific foundation that pure invention could not provide. And it carries within it a deeply attractive notion that the natural world still holds secrets, that not everything has been catalogued and measured, that something from an unimaginably distant past might still be moving through cold water beneath a Scottish hillside. The plesiosaurs were a diverse group of marine reptiles that flourished during the Mesozoic era, between roughly 230 and 66 million years ago. They were not dinosaurs, though they lived alongside them. They were air-breathing reptiles, returning to the surface to breathe as modern whales and dolphins do, and they came in a wide range of sizes and body types. The long-necked variety, the plesiosaurs proper, as opposed to the shorter-necked pliosaurs, could reach lengths of up to 15 meters in some species, with necks that accounted for a substantial portion of that length. The fossil record for plesiosaurs is reasonably good. Their bones and sometimes their body outlines have been preserved in marine sediments around the world, and paleontologists have been able to reconstruct their general anatomy and behaviour with some confidence. What the fossil record shows, with equal consistency, is that the plesiosaurs disappeared at the end of the Cretaceous period, 66 million years ago, in the same mass extinction event that killed the non-avian dinosaurs. There is no credible fossil evidence for plesiosaurs surviving beyond that boundary. This is the first and most fundamental problem with the plesiosaur hypothesis. The geological record is not a perfect archive, and the absence of evidence is not always evidence of absence. But 66 million years is an extraordinary gap. For a large air-breathing reptile to have survived undetected, not just in Loch Ness, but anywhere on Earth, for that span of time would require a chain of circumstances that becomes harder to credit the more carefully it is examined. Loch Ness itself presents additional difficulties. The loch was formed in its current configuration relatively recently in geological terms, around 10,000 years ago, when the glaciers of the last ice age retreated and the valley filled with fresh water. Before that, the region was buried under ice. Whatever lives in the loch today arrived after the glaciers melted, either from the sea via the river systems that connect the loch to the coast, or from other freshwater sources. Plesiosaurs were marine animals, adapted to salt water. There are no known examples of plesiosaur species that inhabited fresh water, and the physiological changes required to make such a transition would have been significant. The suggestion that a remnant population migrated from the ocean into a freshwater loch 10,000 years ago, and has remained there ever since without once producing a body, a bone fragment, or any physical trace, requires a great deal of the fossil record's silence to be interpreted as consent. There is also the question of population viability. A single animal cannot sustain a lineage. For the creature to have persisted in the loch from the end of the last ice age to the present, there would need to have been a breeding population, multiple individuals, reproducing over many generations for 10,000 years. A loch of Loch Ness's size can support only so much biomass. The loch's food supply is relatively modest. It holds populations of salmon, trout, eels, and other fish, but not in quantities that would obviously sustain a family of large predatory reptiles across centuries. And plesiosaurs, as air breathers, would surface regularly to breathe. A population of them in a 23-mile loch, surfacing multiple times per hour, would produce a pattern of observation far more consistent and reliable than the scattered, ambiguous sightings that have actually been recorded. The absence of routine, undeniable sightings is itself a piece of evidence that weighs against the presence of large, air-breathing animals. These objections were articulated by paleontologists and biologists in increasing detail from the 1970s onward. The scientific consensus, when it addressed the question at all, was that plesiosaurs were extinct and that the loch could not plausibly support the population required to sustain the legend. The objections were not made to diminish the witnesses or dismiss the broader mystery. They were made because the evidence, examined carefully, did not support the conclusion. And yet the theory persisted. It persisted partly because it is vivid and satisfying in a way that more prosaic explanations are not. It persisted because the popular image of the Loch Ness Monster, shaped by the surgeon's photograph and decades of artistic renderings, looked so much like a plesiosaur that the two had become almost inseparable in the public imagination. And it persisted because the alternative explanations, while more scientifically defensible, tend to be less interesting. What those alternatives were, and whether any of them adequately accounted for all the sightings, is a question that occupies the next part of this story. Because the plesiosaur hypothesis, for all its problems, had at least the virtue of proposing something concrete. A real type of animal, with a known anatomy, a documented existence, and a clear relationship to the descriptions given by witnesses. The debunking of that hypothesis did not answer the underlying question. It only made it more difficult. If the creature in the loch was not a plesiosaur, if indeed there was a creature at all, then what remained was a mystery without even a proposed solution. A shape in dark water, seen briefly and never clearly, refusing to resolve itself into anything that science had a name for. That is, in its way, a stranger and more unsettling position than believing in a living fossil. And it is the position that the serious study of Loch Ness has occupied, quietly and without resolution, for the better part of a century. There is a particular kind of honesty required when examining the Loch Ness Monster story, and it involves looking carefully not just at what people claim to have seen, but at the conditions under which they saw it. The loch is a large, dark, and visually complex body of water. Its surface is constantly changing, rippled by wind, disturbed by boat traffic, broken by rising fish or diving birds. The hills above it create shifting patterns of light and shadow that move across the water at different times of day. It is, in short, an environment that presents the human visual system with a great deal of ambiguous information to interpret. And the human visual system, when faced with ambiguous information, has a tendency to resolve it into something familiar. This is not a flaw, it is one of the mind's most useful features, the ability to find patterns, to identify shapes, to make rapid decisions about what something is, based on incomplete data. But in the context of Loch Ness, where visitors arrive already primed by decades of stories and images, that tendency can lead perceptions somewhere it might not otherwise go. The most commonly proposed mundane explanations for Loch Ness sightings fall into a handful of categories, each accounting for a portion of the reported encounters, while leaving others less neatly explained. Otters are among the most frequently cited candidates. The Eurasian otter is a native species in Scotland, well established along rivers and lochs throughout the country. When swimming at the surface, an otter holds its head and neck above the water in a posture that can, at distance, suggest a small creature with a long neck. When multiple otters swim in a line, a behaviour that is not uncommon in family groups, the effect can create the impression of a single large animal with humps. At the distances from which most sightings occur, an otter moving through choppy water could produce an impression of something considerably larger than it actually is. Large fish offer another explanation. Loch Ness holds populations of Atlantic salmon, sea trout and European eels, and there are occasional records of unusually large individuals. The European catfish, also known as the Wells catfish, has been introduced to some Scottish waters and can reach lengths of 2 meters or more. A large fish breaking the surface, rolling, or pursuing prey could produce a disturbance that appeared, briefly and at distance, to be something much larger. The Wells catfish in particular has been proposed by some researchers as a candidate for at least some Loch Ness sightings, given its large size, dark coloration, and habit of surfacing in calm conditions. Floating mats of vegetation and decomposing organic matter, sometimes called Loch Ness logs, can rise from the bottom of the loch when gases produced by decomposition accumulate beneath them, lifting them suddenly to the surface. These mats can be several meters in length, dark in colour, and irregular in shape. They rise, drift, and then sink again as the gas disperses. A mat of this kind, rising unexpectedly in still water and then subsiding, could easily be mistaken for a large animal surfacing to breathe. Wakes from boats travelling along the loch can persist long after the vessel that created them has passed out of sight, particularly in calm conditions. A rolling, hump-shaped wave seen from shore, separated from any visible boat, can appear to be a moving animal. The loch is used regularly by commercial vessels, ferries, and private boats, and the wash they leave behind can travel significant distances before dissipating. Then there are the deliberate hoaxes. Beyond the surgeon's photograph, a number of other pieces of supposed evidence have been exposed as fabrications over the years. In 1972, a large carcass was found on the shore of the loch that briefly generated significant excitement. It turned out to be the body of a Greenland shark, mutilated and placed there deliberately. In 1983, a man named Doc Shields produced photographs of what he described as a clear sighting, which were widely regarded as fraudulent. The history of Loch Ness research is littered with such episodes, moments of apparent breakthrough that dissolved, on closer examination, into embarrassment. The cumulative weight of these explanations is considerable. Taken together, they account for a large proportion of reported sightings in a way that requires no extraordinary biology. And yet they do not account for all of them. The cases that resist easy explanation tend to share certain features. They involve witnesses who are experienced observers with no obvious motive for fabrication, who describe their encounter in detail and maintain their account under questioning over years. A retired schoolteacher who has lived beside the loch for 40 years and reports watching an unidentified animal for 10 minutes through binoculars on a calm morning is a different kind of witness from a tourist who glimpsed something from a car window. The psychology of witness testimony is well understood in other contexts. Eyewitness accounts, particularly of unexpected events, are routinely unreliable in ways that the witnesses themselves are entirely unaware of. Memory reconstructs rather than records. What a person remembers seeing is shaped by what they expected to see, what they have seen described elsewhere, and how the story has been told and retold in the time between the event and the account. This is not deception, it is simply how human memory works, and yet this understanding, applied too broadly, risks dismissing genuine observations along with the mistaken ones. The challenge with Loch Ness, the challenge that has never been satisfactorily resolved, is that there is no reliable method for separating the credible from the incredible using testimony alone. Without physical evidence, every account rests ultimately on the word of the person giving it. What remained, after decades of sightings and explanations and counter-explanations, was a body of evidence that satisfied no one completely. The skeptics could account for most reports, but not all. The believers could point to cases that resisted mundane explanation, but could not translate them into proof. The loch held both groups in a kind of permanent suspension, neither confirming nor denying, offering just enough ambiguity to keep the argument alive. Into this unresolved situation came, eventually, a new kind of science. One that did not rely on photographs or sonar returns or human testimony at all, but instead looked for the most fundamental trace an animal could leave behind. Not an image, not an echo, but the invisible biological signature that every living thing leaves in the water it moves through. The answer that emerged from that science was not what most people on either side of the debate had expected. In the summer of 2018, a team of scientists arrived at Loch Ness, carrying equipment that would have been unrecognizable to the researchers who had come before them. There were no sonar units, no underwater cameras, no long lens rigs set up on the shore. What the team brought instead were sampling bottles, filtration equipment, and the tools of modern molecular biology. They were not looking for the creature itself. They were looking for what it might have left behind. The science they were practicing is called environmental DNA analysis, or eDNA for short. It is based on a straightforward biological fact. Every living organism sheds genetic material into its surroundings. Fish release cells into the water through their skin, their waste, and their mucus. Mammals leave DNA in their saliva and droppings. Even microscopic organisms contribute genetic traces to the environment they inhabit. In a body of water, all of this material accumulates. A vast invisible library of biological information suspended in the water column, slowly degrading but detectable with the right tools. The technique had been used with considerable success in marine and freshwater biology before the Loch Ness project. Researchers had used eDNA sampling to detect the presence of rare or elusive species in rivers and lakes where direct observation was difficult. Species that might be present in very low numbers, or that spent most of their time hidden, or that inhabited murky water where visual surveys were impractical. The method did not require seeing the animal, catching it, or finding physical remains. It required only a water sample and a laboratory. The team behind the Loch Ness project was led by Professor Neil Gemmell, a geneticist from the University of Otago in New Zealand. Gemmell was candid about his own skepticism regarding the existence of any large unknown animal in the loch. He did not approach the project as a believer seeking confirmation. He approached it as a scientist who recognized that the method could provide a genuinely comprehensive picture of what lived in the loch, and that such a picture had never previously been assembled. Over the course of the summer, the team collected 250 water samples from locations across the loch, at the surface, at mid-depth, and close to the bottom. The samples were filtered to capture any biological material present in the water, and the collected material was then sent to laboratories in New Zealand, France, Denmark, and Scotland for independent analysis. The use of multiple independent laboratories was deliberate. It guarded against the possibility of contamination or error at any single site, and ensured that the findings could be cross-checked. The analysis involved sequencing all of the DNA present in the samples and comparing it against established genetic databases containing the known sequences of thousands of species. Any organism that had been living in or passing through the loch would, in theory, leave a detectable trace. The method was sensitive enough to identify species present in very small numbers, and comprehensive enough to build a reasonably complete picture of the loch's biological community. The results, announced in 2019, were in some respects exactly what a biologist would have predicted. The team identified DNA from a wide range of species known to inhabit the loch and its surrounding environment: salmon, trout, eels, various invertebrates, birds, deer, sheep, dogs, and humans, the latter almost certainly from the many people who had swum in, boated on, or simply stood near the loch's edge. The biodiversity of the loch, as revealed by the eDNA survey, was substantial and largely consistent with existing knowledge. What the team did not find was any evidence of a large unknown animal. There was no DNA sequence that could not be matched to a known species. There was nothing that resembled the genetic signature of a reptile from the plesiosaur lineage or any other large creature without a known presence in Scottish waters. The survey was not a guarantee. eDNA analysis has limits, and a very rare or deeply reclusive animal might produce traces too faint to detect reliably, but it was the most comprehensive biological survey of the loch ever undertaken, and it found nothing to support the existence of a large unknown organism. There was, however, one finding that attracted considerable attention and generated a fresh wave of speculation. The team detected an unusually high concentration of eel DNA in their samples. European eels are known to inhabit Loch Ness, but the quantity of genetic material present was striking, higher relative to other species than the team had anticipated. Gemmell was careful in his interpretation. He did not claim that the eel DNA proved anything, but he noted that it was consistent with a hypothesis that had been circulating in Loch Ness research for some years, that at least some sightings might be explained by the presence of unusually large European eels. The European eel is a remarkable and still somewhat mysterious creature in its own right. It is a catadromous species, meaning it breeds in the ocean and lives its adult life in fresh water, the reverse of the salmon's journey. Eels from across Europe migrate to the Sargasso Sea to spawn, and the young larvae drift back on ocean currents to enter rivers and lakes across the continent. In Loch Ness, as in many Scottish lochs, eels are common. They are long, sinuous, dark, and capable of reaching considerable sizes in bodies of water where they are undisturbed and well fed. The largest recorded European eels have exceeded 1.5 meters in length, and there is no reliable upper limit established for individuals that have been feeding undisturbed in deep, cold fresh water for many decades. An eel of unusual size, 2 meters perhaps more, moving at the surface or rolling in the shallows, could, in the right conditions and at the right distance, produce an impression of something with a long, curved profile rising from the water. It would not account for every sighting, and it would not explain the more detailed descriptions involving distinct heads and necks and bodies. But it offered a plausible biological candidate that was actually present in the loch in significant numbers and capable of growing larger than most people would expect. The eDNA study did not solve the mystery of Loch Ness. Its lead researcher was the first to acknowledge that. It closed some doors: the plesiosaur, the giant shark, the unknown reptile, with a firmness that previous investigations had not achieved. But it left others open, and in doing so it demonstrated something that the entire history of the loch had already suggested: that definitive answers in this particular place are harder to come by than they ought to be. The loch had submitted to the most sensitive biological analysis available to modern science, and it had given up most of its secrets willingly. Most, but not all. There remained, as there always had, a small residue of the unexplained, not large enough to prove anything, but persistent enough to make complete certainty feel slightly premature. That perhaps is the nature of the place, and it leads finally to the question of why this particular mystery, in this particular loch, has held the human imagination for as long as it has. There is a moment that many people describe after their first visit to Loch Ness. It comes not during the drive along the shore road, or while standing at the viewpoint above Urquhart Castle, or even while watching the surface of the water for movement. It comes later, sometimes much later, when the loch has receded into memory and taken on the particular quality that certain places acquire when you are no longer in them. A quality of depth, of patience, of something that was there long before you arrived and will be there long after you have gone. The Loch Ness Monster, in its modern form, is 92 years old. It was born in a newspaper office in Inverness in the spring of 1933, when an editor chose a single word, monster, and sent a story out into the world that has never quite finished travelling. In those 9 decades, it has accumulated an extraordinary weight of human attention. Thousands of reported sightings, dozens of expeditions, films, books, documentaries, scientific studies, and more column inches than most genuine scientific discoveries ever receive. It has become one of the most investigated mysteries in the world and one of the least resolved. What does that sustained attention tell us? Not perhaps about what lives in the loch, but about what we bring to it. The story of the Loch Ness Monster is, among other things, a story about the relationship between human beings and the unknown. It emerged at a particular moment in history when the natural world was being mapped and catalogued with increasing thoroughness, and when the possibility of large undiscovered animals was receding year by year. The great age of zoological discovery was drawing to a close. The blank spaces on the map were filling in, and into that closing world came the suggestion that something ancient and enormous had survived, unseen, in a dark loch in the Scottish Highlands. The appeal of that suggestion is not difficult to understand. It offered the possibility that the world was still larger than we knew, that the catalogue of life was incomplete, that mystery had not yet been fully domesticated by science. That is a need that does not diminish as knowledge increases. If anything, it intensifies. The more thoroughly the world is explained, the more precious the unexplained becomes. Loch Ness has served that need with remarkable consistency for nearly a century. It has done so partly because of its physical character, the dark water, the depth, the peaty opacity that defeats even modern technology, and partly because the question it poses has never been answered definitively in either direction. The skeptics have not proved that nothing unusual is present. The believers have not proved that anything unusual is. Both positions remain technically open, and that openness is what keeps the story alive. The scientific work done at the Loch has been, in many respects, genuinely valuable. The eDNA survey of 2018 produced the most comprehensive biological inventory of the Loch ever assembled, and its findings about the diversity of life in the water have scientific merit entirely independent of the monster question. The sonar surveys of the 1970s identified real gaps in the understanding of large freshwater ecosystems. The careful collection of witness testimony, begun by Constance White in the 1950s, created a documented record that, whatever its ultimate interpretation, represents a serious and sustained act of observation. None of it has produced the single piece of evidence that would settle the matter. A body, a bone, an unambiguous image, a genetic sequence that matches nothing in any database. In the absence of that evidence, the mystery persists, and the mystery, it is worth noting, is not simply whether a large animal lives in the loch. It is something broader and harder to articulate. It is the question of what we are doing when we look at dark water and see the possibility of something moving beneath it. The people who have devoted their lives to investigating the loch The Tim Dinsdales and the Robert Rinnesses and the generations of volunteers who sat in caravans on the shore with long-lens cameras and logbooks were not, by and large, credulous or foolish people. Many of them were trained observers with scientific or technical backgrounds, people whose professional lives required precision and skepticism. What drew them to the loch and kept them there was something that operated beneath the level of pure reason. A conviction or a hope, or simply a refusal to accept that the question had been answered when it manifestly had not been. That quality, the willingness to sit with an unresolved question without forcing it to a premature conclusion, is not without value. Science itself depends on it. The history of natural discovery is full of cases where the improbable turned out to be true, where the consensus was wrong, where the thing everyone assumed could not exist turned out to exist after all. The coelacanth, a fish believed extinct for 65 million years, was found alive in 1938 off the coast of South Africa. The giant squid, long dismissed as sailor's myth, was photographed in its natural habitat for the first time only in 2004. Nature has a long history of confounding expectations. Loch Ness does not reward certainty, it rewards attention. The loch is still there. 23 miles of dark, cold, peat-stained water, 750 feet deep in places, holding its silence with the same indifference it has always shown. The hills around it are the same hills. The light changes across the surface in the same patterns it always has, creating the same illusions, the same ambiguities, the same moments where something that is almost certainly nothing looks, just for a second, like something else entirely. The sightings continue. They are fewer than they were in the 1930s and 40s, when the story was new and every unusual ripple found its way into a newspaper. But they have not stopped. People still pull over on the Northern Shore Road and stand at the water's edge, watching. They still describe, in careful and sometimes quietly shaken voices, things they cannot account for. Most of what they see has an explanation. Some of what they see may not. The mystery of Loch Ness will not be resolved in this telling because it has not been resolved anywhere. It remains where it has always been, in the gap between what can be seen and what lies below the surface, between what science can measure and what the eye insists it has witnessed. In the cold water of a highland loch, in a valley older than memory, something has held the attention of the world for nearly a century. Whether that something is a creature, or a trick of the light, or simply the oldest and most irresistible human impulse, the need to believe that the world still holds a few things we have not yet understood is a question that the loch, characteristically, declines to answer. It simply waits, as it has always waited, dark, patient and deep,